only 10% of the energy in one trophic level is passed on to the next one above it. So for example, if we have at the bottom of our trophic level some grass that has approximately 10,000 joules of energy, then the trophic level above it will only get around 1,000 joules. So approximately 10% of the energy gets transferred to the level above it. So it's like a 90% loss. And then the energy level, the trophic level above it will only get 100 joules. And it's another 10% loss from there. So why does this happen? Why do we only get 10% of the energy from the trophic level below it? Well, that's because, okay, this concept, first of all, it can be really confusing. I understand that. So let's try to break it down into really simple steps by using a bit of an example. A frog eats a grasshopper, all right? A frog eats a grasshopper, right? So there's going to be a grasshopper here, and then a frog is above it in the food chain. But not all of the energy of the grasshopper is transferred to the frog. Only about 10% of it, right? That's what we're going to try and find out, like, why only 10%? One reason is because some of the energy just gets ingested as feces. By ingested as feces, I just mean, like, in simple terms, your poop. Not all of it. Even as humans, we poop a lot of our food out, right? So they're ingested in a more scientific way. They're ingested as feces. They're just pooped out. Another reason, some parts don't even get eaten. So when a frog eats a grasshopper, grasshoppers have antennas, right? I'm pretty sure they do at least. But for example, they might have antennas, and they're not eaten. Another common example, bones. Bones aren't eaten. Feathers, they aren't eaten. So that's also another reason why. But the third and most important reason is only energy used for growth counts as being transferred to the level above it. So for example, if we have energy consumed for growth, for example, you have your grasshopper over here, and then the frog is only going to get around 10% of that, right? Just draw that a bit better. Only 10% is transferred. Well, so when the frog eats the grasshopper, right? What do I mean by growth? I just mean when a frog eats a grasshopper, some of it's going to be used for movement, because one of the reasons we eat is to have energy to move, right? We need the energy. We need energy for movement, energy to reproduce. Reproduction uses energy. We need energy to, and some of it's just excreted as feces, and some of it is, what else happens? Respiration, that uses a lot of energy too. Some of the energy taken in is used for movement, reproduction, feces, respiration. Yeah, a bunch of things. So not all of it. So by growth, we mean the mass of basically the weight has to increase. Body mass increases. So in simple terms, if we eat a big chicken burger, but our weight increases by 100 grams, that's the body mass increasing. And only the percentage of the food that we ate that leads to this is what accounts for the energy getting passed on from the cheeseburger that we ate. So energy used for respiration, feces, reproduction, or the movement, these all do not count. It's only energy that's used for growth. The one that makes us physically gain weight, the one that makes us bigger, is what counts. So the energy that gets physically stored in our body as fat, essentially. Now we can represent this concept using a Sankey diagram. I try to draw this rough diagram. It's not really accurate, but it's a rough idea. We have the energy that we use for movement over here. 400 joules is used for movement. This does not count. Only 100 joules of the 1,000 joules that the grasshopper provides to the frog is actually used for growth, is actually increasing the body mass of the frog, making it heavier. 200 joules just goes to respiration. 300 joules is excreted as feces. So essentially, this is the only part we care about, the one that actually gets passed on to the trophic level above it. Now we can also calculate the percentage of energy transferred, the efficiency essentially. How do we do that? It's basically the energy transferred transferred as biomass, all divided by total energy supplied. So essentially, if the grasshopper supplies 1000 joules of energy, but only 100 joules of that is efficient, that's going to lead to 0.1, which is about 10% efficiency, which is in line with what we'd expect. Of course, this 10% is just an average. Something might provide 2540 joules of energy, but only about, 200 joules of that might be going to body mass. Well, if you do the calculation, it should be around 12%, I don't know. But roughly, it just needs to be around 10%, that's essentially what we mean. And that's how we represent the efficiency of the energy transfer. And just understand that roughly 10% of the energy is actually transferred, so 90% is lost. And remember, this is the key part. Only energy used for growth, the one that actually increases your body mass, the one that makes you heavier, counts for it. Most of the energy just goes to movement, reproduction, feces, respiration. That takes up a huge sum of energy. And that's why we exercise. If we exercise, it increases our movement, it increases our respiration, and that takes up more of our energy, right? And that's why our body mass decreases, because it uses the energy stored, right? So the movement might become 500 joules, or the respiration might become 300 joules, and that might reduce our growth to just 50 joules. That's essentially what we mean. Thanks for watching this one. I hope it helped.